clams could help us solve one of the biggest climate mysteries on Earth. Specifically, this clam, nicknamed Havrun. Havrun also happens to be the oldest living animal ever discovered by scientists at 507 years young. While we've been fumbling around with barely 2 decades of ocean current data, this ancient mollusk was quietly keeping meticulous records, watching civilizations rise and fall from the seafloor. And what Havrun knows could determine whether human civilization survives these next few decades. Here's our problem. We're trying to predict the collapse of a 1,000-year climate cycle using just 20 years of data. We need centuries of information to understand what's normal versus what's catastrophic. That's where creatures like Havrun become invaluable. Clamshells are essentially oceanic tree rings. Each growth line represents roughly 1 year. These organisms have been automatically recording ocean conditions with extraordinary precision for centuries. Some of these clams were filtering seawater when Isaac Newton was discovering gravity, when the Declaration of Independence was signed, and when the Taj Mahal was under construction. They are living libraries of climate data. What scientists really want to understand from these clams is the AMOC. Think of it as Earth's circulatory system, a massive conveyor belt of ocean currents responsible for our weather patterns, removing carbon dioxide from the atmosphere, and carrying nutrients around the globe. And just like in humans, if the circulatory system fails, consequences are critical. Rising temperatures from climate change could irreversibly shut down the AMOC. Dr. David Reynolds and his team spent 2 decades examining thousands of clamshells under microscopes, hunting for patterns in their growth rings. Their painstaking work created a climate timeline stretching back 1,357 years to the 7th century. This is now the longest annual ocean record ever assembled. And the shells reveal something alarming. Around 1180, several clams near Iceland began recording strange fluctuations. Periods of poor growing conditions became more frequent and longer lasting. The ratio of oxygen isotopes in their shells started oscillating wildly, indicating an ocean climate swinging between extremes. What followed was the Little Ice Age, 500-year cold period that wrecked northern Europe with brutal winters and massive famines, while disrupting rainfall patterns from India to the Amazon. Regional temperatures only dropped about 1 to 2 degrees Celsius, but the impacts were catastrophic for human societies. Think of the AMOC like someone leaning back in a chair. You can lean quite far and still recover, but there is a tipping point where you suddenly topple backward. The medieval clams recorded clear warning signs before the Little Ice Age struck, essentially the wobbles before the fall. Researchers have now found those same wobbles in modern clamshells from across the North Atlantic over the past century. The ocean circulation system appears to be becoming highly unstable again, approaching another tipping point. Unlike the gradual changes that triggered the Little Ice Age, today's warming is happening 10 to 20 times faster. These ancient clams have spent centuries documenting Earth's climate history, and right now, the warning signals are flashing red. The question is whether we're willing to listen before it's too late. If you like science worth sharing like this, then follow us everywhere at Today Learn Science at TIL Science.